You can see AWS free tier will come with some services which are always free. Some are like for a few hours or something. So AWS cloud is very simple to understand. Just imagine traditionally you have a computer. Your computer means like till now what we know. Computer is for like processing something. You can store some data. You have a hard disk and you have a RAM, right? Just imagine the same ways. Even in the just imagine the same thing in a large scale. So when you want to have your data stored, we need to have some storage, and also we should have some compute power for processing something. Just imagine like a RAM. So these are the small things we remember in the computation world. But slowly they evolved, they have a lot of big things. So in the main things, if you see, there is something called as an EC2 instance. Means EC2 means like they give it like elastic compute cloud, something server. Means it's an instance. Means like a server. That server you get 12 months free for 750 hours per month. Per month you can do that much time. Means you need to spin it. I will show you how to spin a server, then how to stop it. But you should ensure to stop, because if you don't do within the time, your billing will be very big. So that's why you should ensure it. At the same time, S3 is like for storage, for storing some data we have. For storing also, there are different ways of storages. Like a files, if you want to store, this S3 bucket is good. And like a database, if you want to store, so this RDS and others are there. You see here, for storage, what they're saying, 5 GB of standard storage free. And you can make 20,000 requests and 20,000 gets and puts, 2,000 puts. Means 2,000 times you can add the buckets and value files. So, and this much time. So in this per month, these are billings, 12 months free. So this is like database is 12 months free. So like that, the main things. And if you want to check what are the always free services, if you click, see DynamoDB first 25 GB of storage every time free. Lambda's 1 million requests every time free. SNS 1 million requests every time free. So like that, there are certain things like developer tools and others, CloudWatch metrics. So some things are every time free. Some things are like free trial, or like so 12-month free as there, right? This one. So this is like, so once you create an account, it's easy. How to create an account? Simple. You go to the free tier, create a free account. That's it. So during the free account creation, it will ask for your email ID and validation. So as I have already an email ID, so when I'm doing a sign up, it is saying like, so hey, you already have the email ID. So if I don't have, it's fine. But if as an account, it will not do. So once you did it, it will ask you to your username, password. It will first validate your email ID. Once email ID is valid, then it will ask you for the credit card details. So it will just for verification, it will do a transaction. That's it. It will not even charge. So it will take the money and again give it to you. So £1 or $1 it will take. That's it. Yes. You see here. Next to see is about in terms of there were like some modules in terms of NumPy pandas is something which we will deal. But there are other modules also down the line you can focus on. But so more firstly to see is about the statistics. As an individual, when you are working on the data analytics, statistics is the most common thing that you get through. So in the statistics is like built-in module. It was introduced in Python 3.4. And if you see the DAR, it has some attributes. Mostly all the statistics related, like mean, median, so mode, multi-mode, these kind of calculations. So you need not understand more about statistics. Slowly you will understand once you start learning it. The first ordinary thing is like the statistical mean, which you do in ordinary day-to-day life. Mean means if you get some values, we need to get the average value means what? So total values count means sum by count. How many values you got? That is the standard statistical mean. That is average we call. So that is arithmetic mean or average. It will calculate. If you give floating point values or any other types also, if there are numbers, it will give the average value. This is statistical mean. So then, like, if you want the fractional values, you can write. Sometimes when you have values, if you are rounding off, the actual value will go. Say like you have 1 by 3. 1 by 3 means like 0.33333. If you just say 0.33, then you are missing the remaining part. And if you are saying 0.34, then also you're missing the remaining part, right? To exactly retain something like a fractional values, you go with fraction modules. So you can give the fractional values also to this, and it will give the fractional result. Similarly, if you want to retain the decimal values, this is again important thing. When you have very large values, if you want to retain the decimals, in general, Python, if you give any after decimal, if you give max, it will retain like, so 6 digits. It will try to round off as much as possible. So if you want to retain as much big, till 16 digits it can store if you go for decimal module. So then, like, if you give that decimal values also, like a D objects I'm giving, that also it can do. Similarly, like means for a float. So the same thing like the above mean, but it will give every time a floating point result. No matter whether it will give, there is a need or not, it will give floating point result. So that is one thing. And similarly, like arithmetic mean, there is another thing called a geometric mean. If you are aware of the statistics, you will understand. So means we are converting the values and we are giving. So ordinary mean means like this. Geometric mean means like this. So like geometric mean, so you have like other things like harmonic mean. So to understand, so you can just Google it. You will understand, like, So hey, I have this one. So arithmetic mean versus geometric mean. So you can have a diagram there. So maybe like I want to show some image to show to understand. So because like math, right? I cannot show directly. Yeah, see here. Yeah, this is clear. In an arithmetic mean, you get all of them combined and you divide by total values. Whereas in geometric mean, you multiply all of them and do a root of that values. That is the difference between arithmetic mean and geometric mean. Similarly, harmonic means is the reverse addition. So inverse of these values you add and you do a root. So versus harmonic mean if you do. So if you say harmonic mean, so if I go for images, then you will understand. Yeah, you see here, I told reverse. You do a number by 1 by x, so and so like this. This is a harmonic mean. So in the same fashion, if I am coming back to the harmonic mean also, I told, right? Instead of you doing the number by so and so, it will do. And similarly, median. Median means the middle value. So middle of mean of middle values means if you are taking some values, in those values, what is the minimum value, mean value it will take? For that, what are the minimum two? So 1, 2, 3, 4, 5 are there. What is the minimum middle value? So middle 5 values are there means remove left 2 and right 2, you get 3, right? Which is the middle value. You get 3. So because there are odd numbers, you got the middle value. Means in the sorted order only it will give. Even if you give unsorted, you give a try. How it works, you see. So within the sorted order, median value it will give. If there are 2 values within middle, means there are 4 values, means even numbers, right? So the minimum 2 are there, 3 and 4 are there. It will take a mean of these 2. So that's why you got like this. That is a median. In the median also, if you get like 2 contention, we are getting the mean of this middle 2, right? So if you want to get the minimum value, you can say medium low. You see, whenever there are contention, 4 values, you got them 3 instead of 3.5. So similarly, median high means whenever there is a contention, you get the highest value. So like median high, median low. And similarly, you have median group. Median group, you give the data and you give an interval, you get it. So you get like the 50th percentile using interpolation. Now from here, the concept of interpolation come to picture. What do you mean by interpolation means like, So you are adding the values in middle. So in data science and this you will understand. So data interpolation between means if there are two data sets, in middle we will add one more thing. Just imagine that, so let's say I have some sequence. Okay, you see here, I have some sequence. I have this first value, I have this last value, in middle one or two values. If I need to have more values based upon the previous and these two, a middle new value will be added. A middle new value will be added. Means a summation of previous two. In middle it will do and it will do. That is called as interpolation. Means synthesizing your own data for your purpose. That is like median. Then like the synthesizing and it will give a median group. That's a point. And based upon the interval, it will give the values will change. And the last thing about this is mode. Mode means you can think like a rank. Most occurred value. That is a mode means. It's a single mode because like how many times one is there? Two times. So two, one time is there. Three, four times is there. Four, one time. Which occurred most amount of time? Three. So three is the most occurred. That's why it is single mode and it is three. And similarly, you see in this case, one occurred two times, two occurred two times, three occurred two times, four occurred one time. Now, which is the highest occurred? One also occurred highest two times, two also occurred two times, three also occurred two times. Now we have three modes. That's why it's called as a multi-mode data. Now, did you understand what is the concept of mode? Highest occurred data. So highest occurred data are more than one. And similarly here, if you see mode, you can understand right here that you have, in this case, when you have multiple modes also, it will give the first occurrence. See here, 1, 2, 3, both are of same mode. That's why you got 1. Now this time I am removing 1 and I am placing 1 in the middle somewhere. Now what is the highest mode it understood? The first highest. Among the highest, first occurred. So we should think like that, not first highest, like this. So that's why it gave 2. Similarly, if you can see here, red occurred, so blue, yellow, so and so, so and so. If all are of same thing, then it will give the highest. So as red occurred more times, 1, 2, 3, 4 times red occurred. That's why it got it. If let's say blue occurred 2 times and red occurred 2 times, so blue occurred first and also it is having highest. So that's why it got blue. So this is the concept of mode. And similarly, multi-mode means it will give all the things which are highest. Mode will give the first highest, first occurred and also highest, right? Like that. Whereas multi-mode means which are all the highest, it will give all of them. If if there are two which are same counts, it will give both of them. If there are two which are same 3, so you got like this. That is multi-mode. So, and similarly, the variance means for each of the value, the next value, how much difference it is there. Let's say how much variation it is going. Let's say today temperature is like 10 degrees, tomorrow is 11 degrees. Means how much variation? 1 degree, right? So day after tomorrow it is 2 degrees. Means suddenly how much it reduced? So 8 degrees it reduced. So that variance you calculate for every two values and finally you give the overall value. That is a variance concept. So variance or second moment about the mean is the measure of the variability of the data. So that variance we give it. And similarly, p-variance. P-variance means same like variance, but returns the population variance of the data. So means like these are slowly you will understand this concept. It's not that difficult. So then now the point is where to use this question. That's the point, right? So when you're doing your data analysis, you will understand like when you're analyzing a data set, how far it is related, whether we need it. So all this information they will ask. Let's say if you are going to financial organizations, they will ask like how much data it is variable. So the financial data we need to calculate. So there you will get a usage directly. If you know these functions, so you will have a usage at the time. So next thing, standard deviation. Standard deviation means, so variance will give the relative change. Whereas standard deviation means from the mean, how much it is varying for each of the values. that it will tell you. So there are like, so quantiles and other information is also there. So this is a very good module, statistics. You will learn a lot of things there. So next, coming to the NumPy, that is a very good module. So this is also a lot of learning. I would say like NumPy is a module which was created initially in the backend in a C language, and the front end connectors were like in Python. Means every Python module will work these days. So what they did is like to make the things faster in the backend. So instead of implementing the entire code in NumPy itself, some part they have implemented in the C language. That's why it is very fast. So this NumPy was also done in the same way. So due to that, they created their own data structure also for that. That's why you see for the first time something called as an array in Python. If you can notice it till now, you have worked on different data structures like list, tuple, set, dictionary. But have you ever worked on something called as an array? No. Only NumPy has this concept of array. In other languages, you might have worked, C language and others. In Python, there is no concept of array on its own. Only NumPy has it. Then what is the difference between a NumPy array and a Python list means? In a NumPy array, all values should be of same data type. So NumPy means like numeric pi, means numerical computations for doing, they created this module. So if you see the documentation, basically it provides an arrays, all kinds of arrays which are homogeneous items. This is the most important thing. Homogeneous means within each of the array, all data should be of same data type. That's the point. And like it will support a lot of mathematical operations, linear algebra, Fourier transforms, random number generations, etc. So some of the things we can do also, but they are ready-madely there for our purpose. Next, you will learn about pandas. Pandas is also mostly created using NumPy in the backend. Now they are making another connectors for pandas too, but NumPy is like a very old module which has a lot of things to do. So how do you create a NumPy array? Same like yours. You give a list, you can create from that. So don't give a set because like you don't know the order which comes, and it would be a bit confusing because set don't have an order, right? You give a list or a tuple, you get it. You give some values, it will take and create an array. When you're creating, you are not saying that it should be an integer array or floating array. But for array to take, you should have all of same data type. In this case, all are integers, right? Then fine, it will take as an array. Now, when it is asking, hey, what is the type? It is saying I'm of type ND array, means n dimensional array. What is that? How many dimensions are there? So generally they say that ND array means n dimensional array. If I say like for this array, if you want to get the type, till now we are using the type built-in function. Now we should use another thing called as the .d type. If I ask d type means the data element type, it will say it is of type int 32. Till now you never seen this concept of 32 or 64. Yeah, this is very smart. Based upon the data that we give, it will convert in the C language in the backend and store, right? So it is storing where these are very small values. That's why do it 32-bit only. If you take a very big value, then it will go to int 64, int so 128, like that it will do. But you don't worry. As a promised in Python language, you need not worry about the data types. But when you're creating, ensure that all are of same type. Now you see here, I am mentioning here these values again, and I'm mentioning float. Hey, don't treat them like an integer, treat like a float. Then it will take everything like a float. And if you ask, float 64. Because for floating point value, there is no 32-bit. Minimum size is like 64. You go to any language, the same thing happens. And now, so here also we can ask length. How many elements means 4 elements. And similarly, if you ask shape, means like what is the dimension? How many values are there? There are 1, 2, 3, 4 values. How many columns? It's just like a one dimension, right? That's why you're not seeing much. This is all about the shape. And next, if you see the np.array, this is like a multi-dimension. You see, I gave 3 values and again 3 values in a float. So don't you see the array now? More clear, right? And if I ask dot shape, Now, did you understand 2 by 3 means? 2 rows, 3 columns. Now, did you understand the difference between length and shape?
2,
Okay.
2, 3, why it is 2, 3?
Yes, please. 2 rows. This is one. This is one. Means this is one object. This is one object, right?
Okay.
Within that, there are again three.
Okay.
3 elements.
Yeah.
Okay. And length means overall at the overview level, 2 values only, right? Length means it will give only the outer dimension. It will not give the entire things. So that is the difference between length and shape. And also type and D type also I told difference. Similarly, you have range, right? Using range, you created some objects. In the same fashion, if you want to create an array, NumPy array with range, there is something called as a range. If I say 15, it will create 15 values. Unlike your ordinary range, if you see ordinary range, if I say a range of 15, will it give a list of values automatically? No. We need to convert to a list, right? For doing. Whereas this NumPy array, it will do it for us. So if you're asking values, by default, same syntax, 0 is the default value. If you don't give, if you give some value, it will take it. So step is like 1 by default. And if you ask shape, yes, there are 15 values, only one dimension. And there is another thing called as the ndim, means number of dimensions in the axis. As there is only one, it says once. If there are multiple things, it will do. Now I have this array. If I want to change this dimension, means like I want to reshape. Shape will give what is the number of rows, number of columns. If I do say that reshape of 3 by 15, 3 by 5, and you see these numbers when you're giving, it should match this number, total number. Means as there are 15 numbers, we can do like a 3 by 5 or 5 by 3. But I cannot say like a 2 into 10. You hope you understood what I'm trying to say. So total there are 15 elements. So what are the reshape you do? That total if you multiply, it should give the same thing. Means 3 5s are 15, right? Or 5 3s are 15. Or in any way with those factors we can do, but we cannot go outside that. That is the most important point when you do reshape. You see reshape, how it worked? So it gave the values, right? Earlier, this array has all these values like this, and I'm doing a reshape. And this reshape will not change to the original object. If you are updating, it will do. Same like yours. Now you see here, it took like a list of lists. So means like list of lists, right? Like that to help you. Now if I ask here, what is the shape? There are 3 elements at the outer list, and within each of them, there are 5 elements. So 3 by 5. And if I ask, hey, how many dimensions are there now? There are 2 dimensions, right? So like that it is happening. And in the same way, if for this NumPy array, dot dtype dot name, each of this value, you see? So dot dtype means type of in name it will give, like in 32. So these are all small values. And similarly, this nd array dot item size. So this array, what are I'm creating, right? Each is having some values. So this item size, the size of bytes of each of the things, because it is storing like a int 32, so it will have a 4 bytes. Means here I mentioned the clear size also. Means 32 means what? If I go with by 8, it will be 4. So 4 bytes we need, right? Hope you know this concept of a bit. 8 bits are called as 1 byte, right?
Yes.
So how many bytes are used means for 32 bytes means like 4, right? So that's what. So 32 bits you are using means like 4 bytes, right? So that's item size. And there is one more thing called as size. Size means it will give the total number of elements. Size means it will give the total number of elements. Item size means, so I told you, right, how many bytes it is using. And you know these things. Next, if I go further into the array again, I created one array like this, one more array. So all elements of same type, it took it, fine. If I ask the type, it says again int 32, fine. If I ask nd array type, if you want the type, my array dot d type you should do, you get it. Similarly, If I give a floating point values also, I can get it fine. And if I want to create multiples also, I can create. That's what till now we have done. Again, just to revise. And this time when I'm passing the D type, you remember earlier you passed a float. So now I'm making a complex. Hey, though they are like ordinary integers, treat like a complex. Now did you see, instead of 1, it is thinking like 1 plus 0j, 2 plus 0j, 3 plus 0j, 4 plus 0j, like that. So like that, you can specify the data type, whatever you want. Or else if you can take an example of doing like D type equal to string. See how it will work. Though you give numbers, it will treat like a strings and it will create. So similarly, or else you can write your custom type also. Means I can write a custom function. For that, it will take a value and it will do the conversion and give the result, like some other complex data type or something. And similarly, you can write like a zeros, like means I have this array, right? Like this array, I want to get the zeros. Means there are 4 complex values. Like this, I want to create zeros. Means it will create a new array containing all values of same dimension, of same type, all zeros only. Did you see? Similarly, if I say ones like, it will create same dimension, all ones. Similarly, if I say zeros like need one array, whereas if you just want to create a zero, you need to give the dimension. Observe, we need to pass a tuple within it. So that tuple is intentional. 3, 4 I give 3 rows, 4 columns. Means 3 objects within that 3, and you got zeros. And if I say ones also I give, so I give like a dimension. So 2 into means 2 objects should be there. Within that each of them there should be 3 by 4, 3 by 4 each. And the type is like np dot int 16. You gave like that. And similarly, if I say ones of 3, if I say 3 objects right now, 3, 1, 2, 3, and within that it should be 4 by 2, 4 by 2, 4 by 2, like that. So if you see here, 2 into 3 by 4. So this is 1 and 2. Within that, like 3 by 4, 3 by 4. Similarly here, 3 into 4 by 2. So 3, 1, 2, and 3. Within that, like 4 by 3. 4 rows, so 2 values each. So like that. And similarly, so you see, ones of 2 by 2 I created and I multiplied with 7. Did you see what happened? All the values got 7. Means if you want, instead of 1, if you want like 32 or 7 or 15, so just you create 1 and multiply with that number. So like see here, where you can specify the data type also, how you want to create, like this. So you understood like 0, 0 like 1, 1 like that. Similarly, there is one more thing called as full. Full means like all values should be of same type. Instead of you specifically writing like, hey, 2 by 2 of 7, you can do like this. Then it will create the same 2 by 2 of the same value, whatever you give. So instead of you doing this once into multiply, like that. And similarly, there is an I matrix. Hope you remember this I matrix in your schooling, you might have learned. So this principal diagonal will be 1. All the others will be 0. If I say I of 4, you see principal diagonal will be 1. All others are zeros. So upper diagonal and so lower, so everything is that. And if I say like principal diagonal, if I say k equal to 1, means did you see this principal diagonal is shifted to 1 level up? So similarly, these ones are shifted 2 levels up from the principal diagonal. And similarly, if I say minus 1, they are shifted to the down by 1 level, principal diagonal. And if I say similarly, I matrix means this kind of things you can play. But you just want like principal diagonal only once and others you don't want, then you go for identity. If you do for identity, you can get like this. No shifting, nothing. You just mention 3, 4, something. Any dimension you mention. 6 means 6 by 6 matrix. 7 means 7 by 6 matrix, like that. Similarly, if you go for random, random means like, you have random dot random of 2 by 3. Means like, I want 2 rows. Within that, 3 elements should be there. So random by default, so the same Python random it will use in the backend. So means like floating point values you get between 0 and 1, random value. And if I say like empty of 2 by 3, this is very interesting. So I initially thought like empty means it should give empty, but it will give uninitiated output, means like garbage. Means previously I created one buffer, right? So this previous object I didn't assign to anything. It will store in the buffer. Now I am asking empty of 2 by 3. As something is already there 2 by 3, it is giving. So next again, if I ask like 2 by 3, it is giving. Because it won't create. If there is something in the buffer, it will give it. So something like a random, but not exactly random. Means previously if someone has created and readily placed, it will give it. If not, it will create something and give you. So lazy random, I would say, something. Similarly, if you create something else again and you store in buffer, will be stored. And if you ask right now empty, it will give it. And now, till now you created 2 by 3. That's why it is a lazy already there it gave. If I say 2 by 4, nothing was created till now. That's why it created something for you. Means if something is already created and stored in the buffer, it will give it. If not, it will create to you and give. Something like a random, but something smarter. For better reusability, it will be used. Similarly, for the A range, I told you, right? Same like range, you can use starting, final, and a step also you give. And if you observe, for an ordinary range, it will not take floating point integers, nothing it will take floats. Whereas A range will take floating point step, floating point is initial value, final value, everything floating point also it can take. So that is the difference between ordinary range and A range. And one more important thing is that till now we use range. Range means what? You give a starting value, you give a final value, and you give the step. In this step, how many values are generated? We don't know. It, it will calculate how many values will be generated and it will give all the values. But in this process, you can have a limit on what should be the starting and what should be the final and what should be the step. But you don't have a say on how many values you want. If you reverse, if you want a thing on the number of values you want, then you go for line space. In line space, same like range, you give the starting and final index. But instead of a step, you tell that I want 9 values. To get 9 values, how much step it need, it will calculate and it will give those many values. And you see here in this case, the step is like 0.25 because I want 9 values. Similarly, if I say I want 7 values, did you see the step is like 0.33? Means step size you are not mentioning. So in range, you mention the step size. So you don't know how many values you will get. You don't have a say. Here you have a say on the number of values, but you step. So whenever you are doing a graphs like a plot graphs and so, if you want like some specific number of values, you will use line space a lot of times. And similarly, if you want like see from 0 to 2 into an np.py, you want like 100 values. If you say you get it, now you can make a plot so that you can get it. Say I created np.sign of x, means for each of these values I want to get the sign. So sign values I get. So these values. Now, don't you think that I can, if I create a sine wave, I can understand, right? For these 100 values, exactly 100 values. For x-axis, y-axis, I can give. So, and do it. I can show that also in Matplotlib if I have time. So, similarly, that is all about that thing. Then A range, the beauty is that for small values, it will give the output. But for larger values, when you're asking, instead of showing the entire output, it will say like this to you. Hope you remember like this we did in REPR lib in the class methods I showed you. So in the object-oriented programming, there is a way, REPR lib by tool. Using that also we can implement. So dunder method, how to do I told there. And similarly, so you create an arrange and you can do a reshape, means you are creating and doing a reshape there itself. So reshape means like rows and columns, how much. So I told you every time when you're doing reshape, if you multiply these two, it should get the total values. So the total count should be the match. And similarly, so we can disable this one. So if you are getting this one, like like this dots, it's easy, but sometimes it will be very irking. You don't know what is happening. If you want to disable that, you can mention this thing like threshold, then it can disable. But again, everything comes with the nodes, advantages and limitations. You decide. else your screen will be very big if you are asking too many values. That also you should be aware. And also one more thing, reshaping, right? Reshape is one way, right? Shape means if you ask, it will give how many values, rows and columns. But there is another way of doing reshape also, automatic. For the shape, instead of a 30, so I did like this. So -1 means like you do whatever you want. Means the row should be 2. So I don't know how many columns should be there, and the other one I give. Means, did you see that it made like 5? Means if you multiply 2 into 5, it is 10. 10 into 3, 30. So you got 30, right? So you can mention like 2 or 3. So if you don't know what exactly to be the other value, just mention -1, then it will automatically do. Now you see here, you see like, uh, again coming back to the basic operations, if I have like np dot array of some values, I got some values. Now this is an array of integers. You see, I gave all of same data type. It's good, correct. And similarly, if I go for a range of 4 means, so it will create 4 values. Initial value will be 0 if you don't give. Final value you give, and default step is +1. So it gave the values. And it also has like 4 values. What is the shape? 4 by 1. It is also having 4 values, 4 by 1. Same dimension. So that's why you are able to add them. So if you add them, so now you got it, right? So now similarly, if I do a subtraction, so how addition is happening? If you observe carefully, the placement, the 0th value is going to the 0th value. So first value is going to the first value. That's why it is saying when you did addition, you got 20. Means 20 plus 0. Similarly, 30 plus 0, 30 plus 1 will be 31. So 40 plus 2 is equal to 42. So 50 plus 3 is equal to 53. Similarly, minus if I do, same in place changes will happen. So it's not concatenation like in a list. Here it will do a in place relations happens. That's the reason I mentioned about dimension. Both should be of same dimension. Similarly, negative minus also in place. So similarly, multiply also in place. So similarly, division also in place. Means in that 0th value, in this 0th value, it will do. As I did a b by a, so bth value of the place will be taken as numerator, eighth value of that particular place will be taken as a denominator, and division will happen, and you get the results. Similarly, what is saying a percentile? What is saying it got like division by 0. For one of them, it got. See, what is saying it is a runtime warning. It is not an error. Observe the difference. So it's not like divide by 0 encountered in reminder. Someone got a divide by 0. Then instead of throwing an error, it will give like a 0. That is one beauty here. You someone call it as an advantage, someone call it as a limitation, but it is subject to how you are seeing this. And similarly, if I do the reverse also, it will work. Apart from this inline operations, we can also do scalar operations. I'm doing a power operation of 2. Means for each of the value, it will do the power, and it will give. And similarly, if I say a range of 3, I'm taking. Yeah, see, if I am doing now a minus d, I will get an error. What is saying is that, hey, I couldn't broadcast. Broadcast error. Broadcast error means don't worry, it is very simple. Both should be of same dimension. The A till now you are seeing is of 1 by 4. Sorry, 4 by 1. 4, right? 4 rows. 1 row and 4 columns. Similarly, B also 1 row, 4 columns. Like that we know till now. But this D when you created is of 3 columns. So that's why it doesn't work. So because it need to do inline operations. Similarly, you see here. So I created sine of A and multiplying it. Like this sine, I can do any trigonometric operation, sine, cosine, so hyperbolic, so cos h, sine h, all the things are there. You can just check it. Everywhere it will go element wise multiplication, element wise computations will happen. Similarly, observe, this is very interesting. If I say a less than 35, means what? For each of the value, it will go and check, and it will give you the answer. For each of the value, it will check and condition. Not only this, any relational operation you give. Relational log, you hope you remember, right? In the starting, we remember. Relational, logical, all operations will give a boolean, true or false. Whatever the operation you do, it will go element wise for each of them, and it will give a true and false, element wise. So as I give it comma, it gave like two values separately. A, it gave that existing array and the condition results. And if I have two arrays right now, and as I told, both should be of same dimension, you gave it. Now I can do multiplication. No, multiplication, if I do, element wise multiplication happens. But do you remember when you go with matrices, there is a concept called as matrix multiplication? If you are aware of matrix multiplication, so this is what happens. If you don't know what is matrix multiplication, and if you forgot, you can just Google it, So matrix multiplication, because I need to give that image for you to understand. How the matrix multiplication happens? This first row and the first column of the second matrix, both we multiply, you get the first element. So second row is second column, you get the second element. So first row, so like this, you need to multiply one row of one table and column of another table. So each value you multiply and you get right. So that is a typical matrix multiplication. So till now what we have seen is about element wise multiplication. But if you want to do matrix multiplication, they created another operator called as ampersand. So from 3.5 onwards, we can use it, ampersand, if you do like this, or else a dot b. So dot is another way to do it. And similarly, you created a num ones of 2, 3, means 2 rows, 3 columns. So 2 rows, 3 columns, you got one value. And hope you remember these are called as compound operations. Means you multiply and also assign to the same object. Hope you remember. Same like that in arrays also we can do. Means now the array will have all values multiplied by 3. Or you can do any expression also like this. For each of the value, it will do the expression and give the result element wise. So it is like element wise operation for all the elements. Next, if I go for like numpy.random.rand, as you know, so random value, and it is taking the value of 2 by 3. So this one is also 2 by 3, this one is also 2 by 3. Both are of same dimension. Then I can do plus equal to b. A means like b value will be a combination of a and b. So element wise it will add and it will give the result. So if I do like another value, see here, b is not automatically converted to integer type. Means you see here, when I'm doing a plus equal to b, it is not doing. But if I do b plus equal to a, that's fine. You see, for a it is like integers. So but b random values, it is a float. So when you did b plus equal to a means b value should be a combination of a and b. A value is existing value is integer. This is a floating point value. So floating point value can take an integer also, right? Can add. So that's why you didn't get any error. Whereas a is an integer, it cannot take a float and add and store. That's what it is saying, like b cannot be converted automatically. So float can take, integer also can do, whereas the int cannot take a float and do. It cannot store, basically. Means we can do operations and create a new object, but as you're trying to overwrite it, it's not possible. That's what you need to understand. And similarly, you know about this concept of ones, as I told, it will create ones of 3, whatever dimension you give. Line space also I told, right? Whenever you are more interested in number of points you want, rather than the step size, you go with line space. Then like I got 3 values. So here also I got 3 values. I'm adding these two like this. So this is a int 32. This is a float. Line space means automatically float. So, and like you are creating to a new object, that's why it is not a problem. You see here. So when you added like int 32 and a float, did you see what is the type? Which are is highest? Float only. That's why you got float. But in the previous problem, what is the problem is that You are trying to overwrite an existing object which is of type integer. That is an reason. Next, so element wise, if you want to multiply with a 1j means a complex value, it will multiply, all becomes complicated. And there is something called as exponential. Do you know the concept of e to the power of something, right? E, mathematically constant, 2 point something, it will be mathematical constant. So that exponential, if you want to do, so you can do this. You get the each values, and it is of type complex 128 bit. And similarly, you see, I created an array with some floating point values, and from this, if I want to get the minimum value, I can say that a dot min, I get the minimum of each other row. So minimum of each of the row, if there are multiple dimensions, then if you try, then it will give the minimum of each of them, and like that. So here in this case, what is the minimum? Minus 234. If I say maximum, I got something. And if I got a sum, means entire things it will add and it will give the sum result. And similarly, if I give the product, the same thing, multiply everything and give the result. And similarly, so there is another alternative way, numpy dot sum of a. So array dot sum also we can do, np dot sum of a also you can do. Similarly, np dot product also you can do, or array dot product also you can do. Both will do the same job. Similarly, what are you did till now? The statistical mean, median, variance, all of them we can do. So dot variance, dot standard deviation, dot mean, dot variance, standard deviation. So with array also we can do those operations. np dot mean, np dot variance, np dot standardization, like that also we can do. So both gonna give the same answer. So this variance you see, this answer, this variance, both are same. Standardization, standardization, like that. And similarly, there is one more thing. You know minimum and maximum. That is very easy for you to understand. Whereas there is something called as the arg minimum and arg maximum. Means whichever is the minimum, if you want that index, that you can go with arg minimum. You see, in this entire thing, you can understand whichever is the minimum. Minimum is minus 234. You know that. Then what is the index for that position? 11, right? I wrote here clearly. From 0, if the indexing is starting, it is going till 11. You got the 11th value. So did you get the 11? Means if you want to get the minimum value index, you go like this. Similarly, if you go to the maximum value, which are is 324. What is its index? 4. You got 4. In the same fashion, see here. So if I give like axis, yeah, from now, this is another interesting thing. Axis means like rows and dimension to mention. So a dot mean, till now if you ask, mean means it will give the mean value, right? If I say axis 0, did you see that it is taking this axis dimension? So 0, 3, 1. You can think like, like a row, you can think. So the 0th values it is taking, you see 0, 3, and 5. That's why I wrote here, 0 plus 3 plus 3. So in the mean, you mentioned like axis equal to 0. Then it took like the 0th values of all of them, added them, and divided by the value, then you got it. Similarly, axis of 1 I give means the first value of each of them it is taking. You see, first value of each of one it is taken, it is doing, and it is giving you the answer. So like that you specify a dimension. See, like that you specify different dimensions, you specify, you get it 0th dimension, first dimension, like that. And in the same lines, we can also have something called a sorted. Sorted means to sorting this array. As you know, sorted is a built-in function which will not, change the original object. So that's why you got it. But if you want to change the original object array, there is a sort attribute. Same like your list. You have here also sorted and sorted. And similarly, I create an array. Now, if I want to get a clip is like I would say, like a slicing, I would say. You see, what I would say here, I got an array of like this. I'm saying that, hey, I want to value that, I want to get the values of 0 to 5. And in the values, there are values which are greater than 0, means they are beyond these limits also, right? You see, there is a 6 is there. 6 is beyond 5. So it was converted to the maximum value 5. 2 is there. 2 is between 0 and 5, right? So it came as it is. Then 5 is there. It is exactly the maximum. You got it. And I got -1. -1 is less than the below minute. So it was clipped to 0. Means if you get the values between these two limits, you get it as it is. If the values are greater than them or less than them, they will be clipped with this maximum and minimum values. Hope you understood what is clip. Next, so similarly, if you have some values and if you want to get the unique values, there is something called as unique. And so in a list, what will happen if you want unique values? First convert to set and give the results. So that is a tedious, whereas it will give like this. And observe carefully, these unique values, every time it is giving, it will give in ascending order. So though you have given the values in different order, you got in ascending order, right? So that is one thing you need to remember. Unique sorted ascending. That is what happens every time. And similarly, for two-dimensional arrays, the diagonal can be extracted like this. If you have like 1, 2, 3, 4, then what is the principal diagonal? So 1 and 4, right? If you can observe carefully, so this it will work like this only, right? It will create like this array of two things, and you have like 1 and 2 and this 1, 2, and you get like 3 and a 4. And what is the principal diagonal here? 1 and 4, right? So like that. So 1 and 4, that's why you got it, 1 and 4. That is diagonal if you ask. If you give it 2, means generally diagonal we ask only for a square matrix. So 2 by 2, 3 by 2, whatever may be. So similarly, if you do a sum, means like compute the sum of all the values. Means like 1, 2, 3, 4 is there. 1, 2 means like 3. 3 plus 3 is like 6. 6 plus 4 is like 10. So that's why we got all the values. NumPy dot sum. But the same sum, if I'm doing based upon the axis, hope you remember earlier also I showed it. Only in the 0th axis, if I want the 0th values summation, first value summation, like that. Axis based things. You see, now I got 4 and 6. How I got 4 and 6? Because like 0th value, it will go. 1 plus 3 is like 4. So 3 plus 4, like that. So dimension wise. So if I say axis 1, or like if I do a reshape, I take an array of 12, a range of 12, and 3 by 4. I got like this. Now you see, I can do in the 0th axis. Axis means like cumulative sum along each row. Each row wise you are getting some, this is very interesting. Like a sum, there is something called as cumulative sum. Sum means what? Till now what you got? In what are the values? You got the entire result, right? Say, if I have this row, so 1 and 3 if I add, I will get 4. So 2 and 4 if I add, I will get 6. Just adding, that's it. Cumulative sum means, so first you created an array like this. In the same dimension you will get. But in the process when it is doing, everyone will get added. Say initially the value is 0. So 0. If I add 0 and 1, I'll get 1. So I got here 1. If I add like, 0, sorry, here, 0, 1 and 2, if I add, I'll get 3, right? So that's why it is 3. And if I add 0, 1, 2, and 3, I'll get 6. That's why it is 6. Similarly, if I had 4 is 4. 4 plus 5 if I add, I get 9. I got 9. So 4 plus 5 plus 6, I got 15. 4 plus 5 plus 6 plus 7, I got 22. So hope you understood what I'm trying to say. Cumulative sum. In the process of its summation, every value will be the summation of previous values together. And similarly, I'm doing in the zero dimension, means like a column ways. So axis 0 means row, axis 0 means column. Or if I just do cumulative sum, for all the values it will do, and it will give the entire resultant values like this. And sum is different from cumulative sum, right? When it is doing summation, it will give the values. Similarly, you can do an exponential, we can do a square root of each of the values. And similarly, If you want to add, you have direct operation like b plus c, and like this also we can do addition. And similarly concatenation. But this is the primary rule, as I told, all should be of same dimension. Type may not be the same, because like until unless you are trying to overwrite an existing object, it will not be any problem. But dimension should be the same. So if you are not assigning, it will assign to a new object, but ensuring that all should be finally of same type. You see, all are float. You have like see 3 different dimensions. Oh, and till now when you are doing addition operation, what happens? It is element wise. But if you want them all combined together, see, that is concat. Till now if you are doing a plus operation, so both are doing in place changes, right? But if you want them all together joined, so that is the concatenation. So for concatenation, all of same type, yes. So all are like 1 by so and so. Yes, you got it. You got it. Now, if I do like ordinary addition, that is not possible. It is saying broadcast problem. Every time it throws an error called as broadcast, you need to understand the same. Broadcast means because of the dimension, it cannot go to each other. That is broadcasting means. And similarly, if we have like 2 arrays, see, you see here, the first array is of 2 elements and 2 elements. And here is like inner dimension like that. So this one we cannot do a concat. Only scalar values you can do. You see, in the first case, each one is having like a, it is 2 by 1. So how many rows? So columns are there, but like rows is 1, rows is 1, rows is 1. Only 1 rows. That's what you can do. Here, how many rows? 2 rows are there. So multiple are there, they cannot be concatenated. So like that, they gave the options for us in different ways. So directly we cannot concatenate. But did you see the difference? If you take like this, you cannot concatenate. If you take like this, we can concatenate. Observe the difference. Means you cannot join them together directly. But if you place within a tuple within it, see here, then did you see 1, 2, 3, 4 came first, and again 1, 2, 3, 4 so and so? Means so you cannot do the do in the axis 0, axis 1 we can do. So axis 0, sorry. Yeah, see here. So like that, if you mention specifically concatenate, you see whether I'm mentioning axis 0 I mentioned, axis 0 I got it. So similarly, if I mention axis 1, means side by side I want like that. Just imagine axis 0 means row. So axis 1 means column. That's it. Row by columns. 0, 1. Like that you remember everything. And similarly, indexing, slicing, and iterating, if you see. Element wise operations happens, if I do like index, I get a 0th value. So so indexing start with 0. So we have like forward indexing, reverse indexing, same rules like that. If you want to slice also will be of type array only. And if you mention, the same old rules are there. And you are saying here that, see here, you are mentioning each of the value to be like minus 100. Means you are taking a slice from 0 to 6, every second value. I want to make it as a minus 1000. See, crazy, right? So you can update like this. On an ordinary list, you cannot do all these things. If you want, like, you take a slice and you do it. And also reverse, colon minus 1, same like a list operation. All of them is possible. So everything you can do like this, like NumPy arrays, you can do a slice. We can that slice you can assign to something else. But that's something very interesting. You see here, I took an array, slice of the array. I assigned to something, and so if I'm doing these operations and I'm changing something to this, so m is the original array, n is the array which I created from a slice, and I'm making some changes. You see, 0 of 0 means 0th value I'm changing to 77. So I repeat again, I have m. M is like this original array. So from that I took some extra thing. In rows I want like the 0 from 0 till 2 rows. I want in columns I want from 1 to 3. Now did you see what I got? Till now we have only 1 dimension slice. This is like a 2-dimensional slice. In the rows, how many rows are there? So I'm saying from 0 till 2 I want. So from 0 till 2 you want, from 0th row, so till 2 you want, but from the columns you want like from 1 to 3. So column means like 1, 2, 3, 4. Sorry, 0, 1, 2, 3, right? So from 1 till 3 columns you want, you mentioned, and the rows you told from 0 onwards till 2. So row means till 2 you want. So that's the reason. So it will go like this. So you see here, now you got the values like 2, 3, 4, 5, 6, 7. Did you see? In rows you want only 2. So from 0 and 2 rows only you want. So first you mentioned these two rows you want. Within that you mentioned that you columns you want from 1 till 3. I mean doesn't include 3 but till 2. So columns also indexing start with 0. This is the first column, this is second column. Like this. Now you got like that. Now what is the point is I took a slice. I got this as a n as a slice. It is not a original array, it is a created from this thing. Means it is actually referring to the same object. So if you do any changes to the sliced value, and did you see your original object is also changing? Means if you take a slice, same like a list, if you take a slice and do operations, it will do it. To avoid it in a list, what you do? You take a copy, right? Here also we should take a copy. That's it. So if you take a copy of that, you cannot, it will not make a difference. And similarly, one more thing. So you have some dimension of functionality and you want to do some operation. You see here, I want to create from function f, from this function, I want to create like a 5 by 4 matrix. 5 by 4 matrix, did I give any value? No. So for that it will go. For index, first it will create a values of 0, 1, 2, 3, 4, 5, 6 like that. And it will do this operation for each other value and you get the result. Sir, how we got like this? For 0th value, so x value will be 0 in dimensions. See, 0 and 0, right? This is 0, 1, 0, 2, 0, 3. That is our dimension if you multiply. So 1, 1, 1, 2, 1, 3 like that. For each other value, so x into 10 means what? So 10 into 1. So n plus 2. So that's why you got like values like this. First it will create based upon the values. 5 by 4 means 5 rows, 4 columns it will create. And the every position, how do you index? This is 0th row, 0 value. So 0th row, 0 first column, 0th row, second column, like that, right? That row value will be x, this value will be y. So those two it is taking and it is doing an operation. So it is crazy. So but like, so sometimes it is needed. And similarly, if you go, this is also slicing. I told custom slicing you take and you can do the operations all like that. And you do indexing, everything is possible. Next, one more thing I want to say. So you created an array like this, a three-dimensional array. 3D doesn't mean like, three are there. So means like within that each values are like this. Okay. Two values starting with, say there are two, two are there. Within those two, each of them, there are again two elements within this. Within this, each of them, there are two. That's why second value is two. And within each of them, there are three. That's why you got three. Now you understood 2 by 2 by 3 means. Now, if I want like slicing, I told so there are three things you do. So row column, till now you have two dimension. Now you have three. So here also you mention. So you are saying like one I want means within these the I want the first value. So means this is the 0th value. This is the first value. I want the first value, and I am not mentioning the remaining details. So if you don't want to mention, you write three dots like an eclipse operator. Then it is indirectly like in the second dimension I want all, third dimension also I want all. No, that's the reason you got entire thing in a different way. Exactly right. Similarly, you are saying like in the first two dimensions you give everything, but in the last dimension I want only the second value. So means so that the thing that you mentioned every second value. So you see here, in the last dimension. So everything you got means in this. So you got like 2 in this second value, means 0, 1, 2 means you got second value, right? And 0, 1, 2 means you got second value 13. That's why you got 2 and 13. This second value, this second value means same dimension you got, every second values you got. That's it. And similarly, if you see here, so for row in so B, you got like each values. And similarly, one more thing, there is something called as flat and a flatten. Flat means like it gives an iterable value, iterator, as it told, means every time you go and get one value at a time, it will read based upon the dimension and give 0 0 value, first value, like that. Whereas if you do flatten, it will generate all the values. Means I have an array which is having all these values like this complex relation. But if you want all the values like in one line, so then like we can do flatten. It will go to each other value and get it. If you have like very much large data, don't go for flatten, go for flat, which is like iterator. It will give one value at a time. That's easy. And similarly, you take one array, you do a reshape, it will change the shape, and then you got it. So reshape we can do anything, but the total number should be equal. 5 4s are 20. 120 is also 20, right? So that's why I did a reshape. And similarly, shape manipulation, as I told. So shape we have taken, flatten I showed you how to do the flatten. So if you do dot flatten, it will do it. So there is one more thing called as ravel. Ravel means like flatten is for like flattening all the things. So return is also like a array only. It will give all of them in the same dimension. You see, you have an array. It is of some shape. If I do flatten, I got all the values from this row wise. First row, second row, third row. All of them it will go. It will concatenate and it will give the result. So similarly, raven also will give the same value. But how different is the raven? Means like, so after doing the raven, if I ask, hey, what is the value of A? Because these things, what are you doing, raven or flatten, they are not changing on the original object. The original object will be of the same shape. And if I do a original A reshape, you get something. Reshape will change the original object, right? So reshape will change the original object. Then like if I ask the transpose means rows will be converted to columns, columns will be converted to rows. So a transpose means you should give like a row value should be transpose. I think like someone I missed here, so you need to just execute it again, it will work. So what are the rows are there? Rows will become columns, columns will become rows. That is the thing. So actually it should not be there. Somewhere I think I messed it. So just re-execute it, you will understand. So the row values will become columns, columns values becomes rows. That is one thing. Reshape, but resize is something else. Reshape means what? The same values will be changing their dimension. You change the dimension, but it will change it. But if you do resize, see, till now we know reshape means what? Shape means like 3 by 4 you go. Means like it will change to 3 rows, 4 columns. And similarly, resize means what? So it is doing what? 2 by 2, 6 is 12. Again, the same values. It is changing it. But the difference between reshape and resize is that resize will kind of trim, I would say. So if there is no option, so it will try to trim it. Next. Yeah. And similarly, if you see reshape, I told, right? If the shape given is like, reshading, yeah. In reshape, I told you this earlier also. When you're directly assigning also, if you don't mention some of them as -1, and if that shape is not there, it will automatically calculate and do. Means if you have some values like, so 2 by 6 means like total 12 elements. If I say 3, what should be the other value? 4. 3 4s are 12, right? So like that. So stacking together different arrays. If I have like multiple arrays, say like I have a range of 10 to 0 to 10 with a 2. A range will give the values like this. So range of 5 means I'll get a values. So here also I'll get 5 values, here also 5 values, same dimension, no problem. So now I took two arrays like this and I'm doing vertical stack. Means it's kind of like concatenation, but like instead of its axis 0 or so and so, I can do like this. You see what is happening? It is doing like first array first, vertically it is stacking, right? One after the other. Similarly, horizontal stack means side by side, means in the same dimension. It's like a flatten. Horizontal stack is like a flatten. So whereas vertical stack is like, concat in an axis. Axis, row, column. Yeah, 0. So similarly, if I go here, so if I have a floor of values, I got it. So I got a floor means, see here, I'm getting these values. So 2 by 2 I'm creating, multiplying with 100, and I'm converting to floating floor values. Floor means what? So if there is a value, say 10.5, what is the minimum dimension? The minimum value integer 10. So it will go to the 10. Similarly, if like floor, there is something like, seal is there, like round is there. So NumPy dot, you can do those operations also. And similarly, vertical stack, as I told just now, I think like, yeah, just now we wrote it, right? Yeah. So vertical stack. So horizontal appending, NumPy dot concat of axis of 0. So similarly, vertical stack means concat of 1. So like that. And similarly, like a column stack. Column stack means column wise they are doing the stacking. So these are like different stacks. So vertical stack, column stack, and so and so. Fine. And similarly, in this kind of repositioning, if you want to mention that you want in a particular size, you can just walk through it. Like a new axis, you can mention. So this is very interesting. I have an array. So this is array A, which is like 4, 2. Just like what is the dimension if I ask? 2 rows, 1 column, 2 by 1, or just 2, it will say. Now if I say A column means what? I want everything in the x-axis, means first axis, and in the second axis, new axis I wrote. Means it will allow you to create a 2D column vector. Means you got the each value, but in a separate way. Did you see like 2 separately? Sorry, 4 separately, 2 separately. And similarly, if you use that in multiple places, in each of them you will get like separately. So you see, I did a column stack of, column stack means after one column another, one after them, is that right? Like that. You got like the A value and like this. New axis means it will create a new array within it, I would say. That's it. Array was created. So it is saying for those values, whatever you do, it will create a new array. For those values you create, it will create a new array. So here also, for those values, whatever you create, it will create. New axis will create a new array for that within it. Similarly, you have some values. So till now you are thinking of adding the values or placing, replacing, stacking. Now to split that, horizontal split and vertical split. Horizontal split means like you have these values in this A, you are splitting by 3. Split A into 3 parts, you are saying. So horizontally split into 3 parts means what? If you can observe A936. So A936 you got. And similarly 49 so and so. Means like first, these parts. Totally how many values it will calculate. It need to divide like this. This is the first part. So this is the second part. And this is the third part. Means third part means like this first do both values you got. This is one array. And this is like second array. And this is the third array. This is like horizontally splitting. And you just made like 3 parts, I want, that's it. Whereas here you told, hey, you split it, but the value should be like 3 by 4. Means I want 3 values. So 3 and 4. So means like split A after the third and fourth column. Means like after the third and fourth column, it is splitting. You see here how many splits it is. So you are mentioning like how many splits. So you didn't mention, but after when you want to split, you told. So like that. Similarly, vertical split will happen on the vertical axis. just that give a try. And this is most important, as I told earlier. Whenever you are taking a copy, what is the point of having a copy? What is the thing? So you have an array and you are assigning. Even in the you see, in a NumPy array, whenever you are assigning a value to another value, it is a very difficult problem, because if you make changes to one of them, it will reflect in the another also. So to avoid this problem, in an ordinary list or a dictionary or so these are mutable objects. There, what we did, we used the copy module. So copy and deep copy. In the same fashion, here also the same problem is there. So when you do an assignment, so instead of no new object creating, both will refer to the same object. That's why when you do a is operator, it will say true, and the address locations are also same. So that's why we should very careful, because if I do the shape of, I'm doing the reshape. I took a, I'm generally a means like 12 means like 0 to 11, you will get a value, all in the same dimension. So 12 columns and one row. But if you do a reshape, so B you are changing. And after that B, if you ask, hey, what is the value of A shape is also changing. Means what are the changes you do on one object will reflect to the other. To avoid this problem, we need to have a copy. So how do you take the copy and what is the point means? Here, for any array, if you do a view, so for a list, we have like a dot copy, list dot copy. For a set dictionary, we have a dictionary dot copy. Like that, for array, we have like array dot view. So that copy is called as a view here. In pandas, it is called as a dot copy. Here it is a dot view. So if I do a dot view, now if you see, a new object is created, new array is created. And if I say is operator, it is false. If I say address locations, first two are created using assignment, that's why they are equal. The third one is created using view, that's why it is different. So, but can I know that is it created from this source or not? For that we have like dot base. For any array, if you ask dot base, it will point out from where it was created. So that view was created from A. That's why C dot base is view. Yes, it is correct. Who is the owner of this original array? That we can get. And similarly, now if you do any changes also, it will not reflect to the other. So see, if I change the dimension, so it is not changing the original dimension. A is not affected. And similarly for C, if any element if you are changing, so the C is having the effect like 123, 1234, but the A is not having the effect. So that is the safe way of creating a copy in NumPy. And similarly, if you do a slice, if you take a slice from a array and you do operations on that array slice object, so in fact this S is not a new object. It is referring to the location of this A array only. That's why if you make any changes to it, even the original object also will have the changes. So that is the point. So if you want to create a slice, for slice also you do a dot view, or you can go for a deep copy. So copy also we can go. So copy or view, both are doing the similar job. So copy method is like a complete copy. I mean, what is the difference between view and a copy, sir? Means copy is like a deep copy. The difference is very simple. When you have an ordinary array, which is having an one dimension, if you make any changes, if you do a view, the view will ensure that the changes will not reflect. But if in the ordinary array, if there are multiple dimensions, then what are the changes were there? There will be slight leakage. To avoid that, we can go for a deep copy, which is like a dot copy. But sir, why can't we go directly to this? Yeah, most of the time we can go with it. That's the best way. But it will be slightly more expensive in terms of performance, because it need to do all the things. And if you see the a dot view, for a view, if you ask, hey, what is my base? It says like the original array, right? But when you do a dot copy, if you ask, hey, d dot base, it says like it's not, A is not my base, because it will forget everything about it. Means entirely new object will be created. So he's saying like d dot flags dot own data. Is it its own data? Yes, it is true. As if it was a new data which was created, new array, it, it will show. Earlier you saw it was not the same. Similarly, so in the broadcasting rules, I told about the indexing and all these things. Some things are like again repeating, but like indexing, slicing, all rules I told. There is nothing else newly to specify. I think like simple array operations and all these things. Yes, transpose I told, right? So the rows will be converted to columns. Columns will be converted to rows. A dot T you can do, transpose you can do. Did you see that the first value is like that, first value is like this? Principal diagonal will not change. You see this value is changed to this position. So this position you see here. So rows will convert to change. That's why in principal in a non-linear means like not a square matrix you can see, rectangular matrix you can see the things. And similarly we can do that linear algebra. So linear algebra is a separate subsection. In linear algebra we can do a lot of things. We can see like so Cholesky conditions, determinant, so like eigenvalues, eigenvectors, so inverse linear algebra, so matrix power, matrix rank, matrix dot, normalization. So these are like linear algebra, so typical things. So all of them we can do, tensor inverse, test, and all these things. So the I matrix, which like identity matrix. If you give any size, it will give a square matrix of that much, where principal diagonal is one solve, and you can work on it. And the matrix product operation, as I told. And similarly, there is something called as trace, summation of principal diagonal. If you want to get the sum of all principal diagonal, you have trace, and like you have all these values. And if you do like so linear algebra dot solve means you give an array and you give some other thing, and it will solve it. Or like eigenvectors, a lot of things are there. Whenever you have some free time, just walk through it. This is all about the NumPy arrays, which I want to pass. And